evening, class. I'm going to go ahead and record a couple of problems that I have for tonight's homework. So I wanted to do problems number 16 and 23. And then I'm going to do problems number 34 and 45. Alright, so let's look at the first one. So for the first problem, we need to get this third root by itself. So I'm going to go ahead and I'm going to add 7 to both sides to try to isolate that root. So it's going to give me the third root of 16x equals 24. So to get rid of the third root, oh, you know what? I forgot something in the problem. It's 3 times the third root. I was thinking that's going to be a really big number, but it's 3 times the third root of 16. So to get rid of that 3, we're going to divide both sides by 3, right? So if we divide this side by 3, we can divide this side by 3. So that's going to give us what? The third root of 16x equals 8. So then to get rid of the third root, we're going to raise both sides to the third power. So that's going to give us 16x equals 8 to the third power. And 8 to the third power is 512. So then we're going to divide both sides by 16. And we get x equals 32. So that's the first problem. For the second problem, we're going to do the same type of thing, but instead of having the root, we have x to the 3/2 power. But remember, we can write that as the second root of x to the third, right? That's the same way. So this is the radical form of this, x to the 3/2. So the first thing I'm going to do is divide by 2. So that gives me x to the 3/2 power equals 8. So to get rid of this 3/2 power, we're going to raise both sides to the 2/3 power. So we're going to multiply by the reciprocal of the power. Alright, I don't know why I made that parenthesis. So if we think about this side, remember, a power raised to a power we multiply, so that's going to give us x to the 6/6, right? Which will just give us x to the first, which is x. So on this side, remember, x to the 2/3 power is the same thing as writing the third root of 8 squared, right? So we take the third root of 8 first. So the third root of 8 is 2. Then we have 2 squared, and 2 squared equals 4. So the answer for 23 is 4. So let's look at 34. So 34 is going to take us just a little bit longer than the other ones, but so I have the square root of 3x. To get rid of the square root, we're going to square both sides. So we have to square the entire side. So remember, x minus 6 squared is x minus 6 times x minus 6. And then the square root of 3x squared is just going to be 3x. So then I'm going to FOIL this. So x times x is x squared. X times negative 6 is minus 6x. Negative 6 times x is another negative 6x. And negative 6 times negative 6 is positive 36. So now I'm going to combine like terms on the left side. So it gives me x squared minus 12x plus 36 equals 3x. I'm going to subtract 3x from both sides. So that gives me x squared minus 15x plus 36 equals 0. So then now here we can either use the quadratic equation or we could solve. This one's actually easily factorable, so I'm going to go ahead and factor this. So we have x and x. The factors of 36 that would give us 15 are 12 and 3. So since it's minus plus, it's a minus minus, so minus 3 and minus 12. So then we set each factor equal to 0, and we get x equals 3 and x equals 12. So it says to check for extraneous solutions. So to do that, we just plug it back into the original equation. So we're going to do 3, plug 3 back in, so we get 3 minus 6 equals the square root of 3 times 3. So it would give us negative 3 equals the square root of 9. So then negative 3 equals 3, or it does not equal 3, so then we would say this is not a solution, right? So that would be considered an extraneous solution. So let's check to make sure 12 is the solution. So we'd say 12 minus 6 equals the square root of 3 times 12. So 12 minus 6 is 6. 3 times 12 is 36. So we get 6 equals the square root of 36, which is 6. So that does check out. So 12 is a solution. So 12 is the only solution for this particular problem. And then the last one I wanted to do is 45. So since 45, both of them are square roots, so we have the square root of 4x plus 1 and the square root of x plus 10, we can just set their radicands equal to each other. So we're going to say 4x plus 1 equals x plus 10. So anytime the index is the same on both of them on both sides, we can just set their radicands equal to each other. So if that doesn't make sense to you, you surely could just square both sides, and then you could see that the square and the square root are just going to cancel each other out on both sides. Right? So that's going to happen each time the index are the same. So then I would just solve this. So I'd subtract